Hello, and welcome to Learning with Miss Ward. Today we're going to be going through the concept of two-sided variable equations. Please grab a pencil and a journal to take notes with, and we're going to get started. All right, so first let's talk about some things. Concept reminder. Equations are simply balances. An equation is just two expressions separated by an equal sign whose values are the same. So let's look at our balance. We have one expression that's 3 times 2 and another expression that's 9 minus 3. Both of their values are 6 and they are separated by an equal sign. Now the numbers are different and the operations are different, but the values are the same. That's really important. All right, let's keep going. Okay, so now we're moving on specifically to the concept of double-sided equations, specifically looking at double-sided variable equations. The equation we have here is 4 plus 2x equals 4x minus 8. Let's draw a picture to represent this equation. All right, so let's look at the picture that was drawn. We have 4 open or unshaded circles to represent our constant 4. We have 2x represented with 2 groups of x. On the other side of the equal sign, we have 4 groups of x that represent 4x and 8 shaded in circles to represent negative 8. Now, before we get started, I want us to be reminded of some other concepts we've learned before. First is like terms. Like terms are simply terms that are within the same category that can be added and subtracted between them. For example, 4, which is a constant, and negative 8 is a constant. You are able to add and subtract between them because they are the same category of terms. Now, if I look at 4 and 2x, they are not like terms. 2x we can see has an x and a coefficient of 2, and we see 4 is by itself. We are not able to add and subtract between them, so they are not like terms, and we cannot simply put them together. Now, when it comes to another like term of 2x, you're probably like, well, how about the 4x? Absolutely, they are like terms. We are able to add and subtract between them. And because of that, that's simply what we're about to do. Now, the next concept is understanding that to find the value of x, we must isolate x. To be able to do that, that really means we're just trying to get this x by itself. And the best way we're going to do that is getting it to the right of the equal sign, just because it's going to be a little easier for us. So what I'm going to do is take away 2x. I can do that because of the concept inverse operation. Inverse operation is just simply computing the opposite operation. So for example, this is 2x being added. I'm going to subtract 2x because that is the opposite. And because this is an equation and equations are balances, whatever I do to one side, I have to do to the other. So if I'm going to take away 2x on the left, you got it, I have to take away 2x on the right. So let's do that. Let's subtract it. Okay, so look what we have left. We have 4 circles still, positive, may I add. And on the other side, we have 2 groups of x, and we still have our 8 shaded in circles, which represents our negative 8. Perfect. So now we have isolated that variable. Once again, because of like terms, we want to get the other like terms together, which means that if we have 8 circles over here, we're some way trying to get this constant on the other side with its friend 4, which is also a constant. Now, how are we going to do that? Very similar to just what we were speaking about with inverse operation, which is the same thing, but this way we're going to see how it works, is zeroed pairs. Zero pairs allows us to see why inverse operation we are computing with double-sided equations helps us out so much. So what I'm going to do is zero out all 8 of these circles. So what does that mean? I'm going to draw a positive circle that is not shaded in. And because that's basically saying 1, which is positive, minus 1, which is basically saying 1 and a negative 1, makes 0, right? So another way to look at that is if I were to do 1 minus 1, we all can agree that's 0. So that means that zeroes out. So now I've done that to 1, I'm going to do that to the next of the 7, which means I have to add 7 more circles to zero out all the negative 8s. So let's do it. All right, so I've zeroed out the rest of the negative 7s, or the rest of the circles, which now means we have 0 pairs, and there's basically none of this is left over here. But because I added 8 positive circles to one side, I'm going to have to add 8 positive circles to the left. And the reason why is because it is a balance. Whatever you do to one side, you have to do to the other. So let's draw 8 circles that are not shaded in to the left side. Okay, so now that we have done so, we should now see we have 12 circles all together because we can put a positive 4 with a positive 8, which adds to a positive 12. Now that I've done so, and we know this is 0 pairs, I can erase all of that. So let's do it. All right, so look what we're left with. 2 groups of X and 12 positive circles. Remember, it's positive because they're not shaded in. So now we want to know what the value of X is. So how can we do this? We're going to divvy up each circle so each group of X receives a circle. Once we have done that, you'll be able to see that 6 circles equals a group of X, which tells us that the value of X is simply 6. X is 6. Nice job, guys. Let's try this again, now doing it numerically. Okay, so now working with the same equation, 4 plus 2x equals 4x minus 8, we will continue, but this time, instead of doing it pictorially, we're going to do it numerically. You'll see I have a solving side and a checking solution side. I'll go over the checking solution side later. I just wanted you to notice that it's there because it's important to have. Okay, so let's start. I'm first going to remember that 1, equations are balances, so whatever I do to one side, I have to do to the other. That 2, my goal is to get this variable by itself so that I am able to solve for it. And 3, I'm going to use like terms to be able to complete that action. So we already know that 2x and 4x are like terms. So I am able to add and subtract between them. But before I can even do that, I have to isolate the variable by getting the 2x away from the left side of this equation. I am able to do that with inverse operation. I am going to subtract 2 because that is the opposite operation of adding. So now I get to zero this out, and because I did this on the left side, I'm going to subtract 2 on the right side. Once I do that, I am able to bring down everything else. So now I can see that 4x minus 2x is 2x. I can bring down my equal sign, bring down my positive 4, and bring down my negative 8. That now leaves me with 4 equals 2x minus 8. I'm going to continue with the concept of like terms to isolate this variable. I am going to add 8 because that is the opposite operation of this negative 8 or subtraction of 8. We did the same thing pictorially by adding 8 circles to those negative 8 circles. We were able to see that each one of those pairs were zeroed out. So that is how inverse operation works. So I am able to zero this out. And just like I did pictorially by adding those 8 positive circles to the left side, I'm going to add 8 just to keep our equation balanced. Now I can do 4 plus 8, which gets us 12. Bring down my equal sign and bring down my 2x. Now we have 12 equals 2x. Perfect. Now I'm going to do the inverse operation again by doing the opposite of multiplication, which is what's happening here when you have a number with a variable, and I'm going to divide. This is the same thing as when we divvied up those 12 positive circles between those two groups. Once we did that, we were able to see that the value for x was indeed 6. Perfect. So now, you guys already knew this part. You already knew that we're going to get the value of 6 for x. Now, we want to just check to make sure this is true. And by doing that is we're going to use a concept called substitution to substitute 6 for every time we see the x in this equation. The reason why is because we want to see the values for both of these expressions being the same. So let's look at that. So I'm circling all my x's so I can remember that they are going to now be 6. So I'm going to rewrite this equation. I'm going to rewrite it as 4 plus 2 times 6. And remember, I'm doing that because it's multiplication anytime we see a number with a variable together. And then I'm going to do 4 times 6 again after I put my equal sign and minus 8. Okay, so I'm going to bring my equal sign down again, and now I'm going to multiply first. The reason I'm going to multiply is because of order of operations. So 6 times 2 is 12, and 6 times 4 is 24. Now I can bring down my negative 8 and my positive 4. So now we're just going to do simple arithmetic to be able to see what the values of each of these expressions are. So let's bring down our equal sign and solve for each of these expressions. Once you solve for both of them, you should notice that they both have the value of 16, which is great because that means we solved for the value of x correctly. Why? Because the values are exactly the same, which is what we wanted to see. Fantastic. We're going to continue practicing computing numerically, double-sided equations with variables with a brand new equation. Let's go and do it. Okay, so we're coming in for a landing. Yay! We have a brand new equation. 20 minus 7x equals 6x minus 6. Perfect. So we're going to put everything together that we've learned thus far to be able to solve for the value of x here. You'll see I also have a checking solution side so that at the end we can check to make sure we did this correctly. Okay. So first I'm going to do inverse operation. I'm going to add 7x to zero out this negative 7x. And because this is an equation, whatever I do to one side, I'm going to do to the other. I'm going to add the 7x to 6x because they are what? Like terms. So now I have 13x, and I can bring everything else down. I'm going to bring down that negative 6, bring down my equal sign, and bring down that 20. Perfect. So now I have 20 equals 13x minus 6. So now, once again, I'm going to do like terms by putting the two constants together, which is 20 and negative 6. First, before I do that, I'm going to do inverse operation again. This is a negative 6, so I'm adding that 6 together. So by adding the 6 to the negative 6, once again, we are zeroing it out. And whatever we do to one side, we have to do to the other. So I'm going to add 6 to that 20, which now that gives us 26 equals 13x, which we're bringing down. Okay, we've already spoken about that. When a number is next to a variable, that's multiplication. We are still trying to get this variable isolated. So I am going to divide because that is the opposite of multiplication. Now that I'm dividing, to make sure this x is truly by itself, I'm going to divide by 13 and divide 26 and 13 as well. That will end up showing us that it's 2 that is the value for x. Perfect. So now that we know this, we want to check if we're correct. So what are we going to do? You got it. We're going to substitute that 2 in for x. So every place that I see x, I'm going to put a 2. Good. Just going to circle that just so we can have that. So let's keep going. This part should be relatively easy. Now let's rewrite the equation. Okay, so we just rewrote the equation as 20 minus 7 times 2 equals 6 times 2 minus 6. So let's bring down our equal sign. And we are also going to do multiplication first because of order of operations. So let's do negative 7 times 2, which gives us a negative 14, and a positive 6 times 2, which gets us a positive 12. And now we can bring down our negative 6 and our positive 20. All right, so now our goal is to see if we get the same value for both of these expressions, which means our equation is indeed balanced. And if it's balanced, that means that we correctly solved for x. Let's see what happens, guys. Okay, so 20 minus 14 is 6, and 12 minus 6 is 6. Awesome. So you know what this tells us? Yay! We have solved correctly for x. X is indeed 2. And how do we know? It's because both of our expressions have the same value. And because they have the same value, that means our equation is true and they are balanced. Nice job, guys. Thank you for learning today with me. If you have any questions, as always, email me. Have a great day now.